Autonomous 3D modeling of target structures using aerial robots is fundamental to human progress. It guides disaster response, preserves heritage, assesses infrastructure, and builds smart cities. However, existing solutions still fall short in open-world environments. They rely heavily on effortful priors, such as manual setup or pre-existing maps, to instruct which regions aerial robots should scan, and often require offline human intervention, like geometry processing during the mission. Additionally, rescanning is frequently necessary due to incomplete scans. Together, these factors largely limit their practicality, operational efficiency, and generalizability to diverse scanning missions. Foundation models have recently demonstrated outstanding generalization across fields, offering significant potential to close this gap. We explore empowering drones with foundation models. Our FlyCo enables fully autonomous, precise, and practical aerial scanning of diverse target structures in unknown open-world scenes. The system is driven only by low-effort human prompts, without effortful priors or heavy human involvement commonly required in existing paradigms, improving operational efficiency and flexibility. Tested in 4 in-the-wild scenarios without any prior knowledge, our system efficiently and reliably scans human-intended structures. The first test confirms our system's ability to understand complex real-world structures and accurately scan the human-intended parts. Here, an arch bridge in a connected building. The mission starts with a non-expert's natural language request and a box on the screen. Our system instantly understands these inputs. It precisely segments the target bridge and predicts its full 3D shape as foresight guidance for planning. Despite significant challenges from visual similarities and spatial connectivity, it achieves a stable segmentation by leveraging foundation models. The small inset shows that as the drone gets more observations, its surface prediction gradually matches reality. Together, these support a focused, adaptive scanning flight. The scanned data is transformed into a full digital copy, capturing the complex bridge in sharp detail. Foundation models give our system human-like 3D imaginative abilities. Our second test, on a large concert hall between hills and lakes, highlights a key challenge. For such massive structures, sparse initial observations make this imaginative inference more difficult. However, our system overcomes this, correctly inferring the target's full shape. With new observations, the system continuously improves its predictions, reducing uncertainty and aligning with ground truth. This robust foresight enables highly consistent and efficient flight over the 1,000-meter mission, avoiding frequent direction changes, detours, and redundant scans. The third scenario, a castle gate surrounded by park trees, demonstrates how the system's joint scene understanding and flight skills rise to more challenging cases. This mission involves multiple challenges. As the gate is the entrance to a driving school, there's frequent pedestrian and vehicle traffic. The flight is further complicated by surrounding woodlands, small structures, and thin wires. Facing these challenges, the system assures safety by dynamically adjusting trajectories and uses stable target segmentation and predictive guidance empowered by foundation models for efficient aerial scanning. Lastly, we show the system in a more cluttered environment, scanning a red brick building in a dense forest. Leveraging foundation models, it interprets prompts to accurately segment the target building, even near a similar structure, and also makes reasonable predictions, capturing details like its 2 towers. The system then executes the mission safely. The navigable space is severely constrained by dense trees and nearby structures. Despite these high-risk conditions, it plans collision-free paths, constantly keeping a safe distance from all obstacles while efficiently ensuring comprehensive target coverage. Overall, empowered by foundation models, FlyCo addresses limitations in existing solutions and truly achieves performant aerial target structure scanning across diverse open-world scenarios.